Okay. How do I put this into? Oh yikes. Okay. This is awful. View. There it is. I literally lose it every single time. Anyways, so before I start with the basics of just some assembly, I want you to not take this too seriously, okay? I don't expect you to understand everything. Hell, I barely fully grasp this ever since I started reverse engineering, and I realized I never even started this course, but I don't want you to focus too deeply on the things I'm going to teach. These are just some basic things to take note of and know in the back of your head for now, okay? So, not this part. This is just this you can actually pay attention to. So, why do we use assembly in reverse engineering? Well, if we don't have access to source code, say an application is written with C++, we'd need to resort to assembly. And also, disassemblers like IDA or what's it called, or GDB, these all use assembly to disassemble the program. So basically, they take the machine code, ones and zeros, and it shows you that in assembly. We can understand program instructions way easier. Every single every single step of the program is shown. So if a function call happens, what happens in that function, everything. You will get examples of this. I'm not going to show them right now. And you can stop at a specific instruction. Say you are storing the value of 8 in a variable called a, so int a is equal to 8. You can stop at that instruction. You could possibly modify that value, manipulate it. Just for hacking reasons, it's not really that important. And you can look at data stored in the stack or in the heap. And by heap, I mean dynamically stored data, which is global variables and stuff. I'm sorry, what am I talking about? Sorry, like memory allocation, yeah. And these are some general basic, general purpose registers, operands. I'm not gonna go too deep into them, but these are, you can think of them as variables, so they would hold some value. Like EAX can hold a value in a variable assignment operation. So again, int a is equal to 8. So that could possibly be stored in EAX, or EAX could be a function's return value, right? Again, just variables that hold data. Like ECX could be a loop counter, whatever. It doesn't matter. These are just meant to hold data. And the lower halves of those, so just 16-bit data registers. I will show examples of all of this. So it's AX, BX, CX. Also, 64-bit registers start with R's. So this would be RAX, RBX, but I'm not gonna show 64-bit yet. And lower halves of the 16-bit registers, so 8-bit registers are H, right? AH, AL, BH, BL, CH, CL, whatever. I'll cover all of this. I'll show examples. So just think of these as variables that hold data in the assembly language. And some other ones are ECI and EDI. These are used in data transfer operations. So say you're using the printf function and you are transferring a string um, into your format string. So in the C language, when you want to print a string, you have to move that string into the string buffer of the printf function. So the ECI would be the string buffer, and the the EDI would be the printf function's buffer, and ESI would be the string that you're passing in. I'll show examples of that. And these are pointer registers. You have your EIP. It holds the address of the next instruction to be executed. I will explain this again. Don't worry about any of this. Your stack pointer, it points to the top of the stack. It's the last thing that was pushed onto the stack. And your EBB is the base. It points to the base of the function. And it's used to locate variables. Say you want to move a value into a variable. The assembly language actually needs to find where that variable is, and it uses that with EBP. I will show examples of that. And these are some other registers. We have your carry flag, you have your interrupt flag, your zero flag. These are used in conditional operators, so if something's equal to something else, sometimes it's used in those. One example is the str compare function in the C language. What's it called? It basically the return value of string compare. Let's say you're comparing two strings. The return value, because string compare is a function on its own, so the return value of the string compare function will yield a 0 if those two strings are actually equal. So the 0 flag would be set in this case, right? So it's just an example of, for example, the 0 flag.